Well, hi, hello, and welcome. In this screencast, we take a look at how to solve systems of linear equations. This is a topic I assume you have read about because that is something I would have asked you to do before you came to this video. It is also very familiar for high school students. So this is something that I'm expecting will go pretty well. Let's take a look at a couple of kinds of systems of linear equations. This is one of the more common. So we have a system 3x plus 2y equals 7 and y equals negative 2x plus 5. Now, to be clear and to remember, this first equation represents a line on graph paper. This second equation represents a line on graph paper. We are looking for where those two lines cross. We will notice that in the second equation, y is all by itself. And so we can use the substitution method because y is all by itself, and we can take this thing that is y and we can substitute it in the other place where y is. So that first equation is 3x plus 2y equals 7. 3x plus 2y is 7. 3x plus 2y is 7, but this y is this y. And so then we have one equation with one variable, and this is something we should know how to solve, right? We use the distributive property to solve that. I'll pause a moment to let you do that. You could hit the pause button yourself. Okay, so that's positive 2 times negative 2x, positive 2 times positive 5. And we're looking at negative x plus 10 is 7. Then we subtract 10 from both sides. And so what's x? X is 3. How do you get yourself a y? Well, y was negative 2x plus 5. Negative 6 plus 5 is negative 1. And so we're looking for the point where the two lines cross, and that's 3, negative 1, x comes before y, x comes before y, x comes before y. So we have found the point where these two lines cross. Well, it's not always that easy. Let's solve 2x plus 3y is negative 4, and negative 3x plus 2y is 19. In this system, neither x nor y is by itself. So what do? Well, in this case, we work with something called elimination. And when we eliminate, we are eliminating either the x's or the y's. It is usually convenient if one coefficient is positive and the other coefficient of the same variable is negative. It is usually helpful to try to get those coefficients to match with opposite sign. How do we do that? Well, we think about a number that 2 and 3 both go into. We think 6. So how do we get a 6 with that first equation? We multiply both sides by 3. How would we make this a negative 6? We'd multiply both sides by 2. So this first equation becomes 6x plus 3 times 3y equals 3 times negative 4. This equation is exactly the same as this first one. There's just a constant multiple on both sides, no problem. And then down here, 2 times negative 3x, 2 times positive 2y, 2 times 19. But what's the advantage here? Well, if we add straight down, 6x and negative 6x go away, like you will in 5 minutes when this video is done. 9y plus 4y, negative 12 plus 38, and oh look, that solves really nicely. once y is 2. How do we find an x? Well, that's not bad either. The first equation says that 2x plus 3y is negative 4. Could have used the second equation. First equation is just fine. So 2x that's a plus 6, subtract that over, and then divide by 2. And so we have x is negative 5. We're looking for the ordered pair where these two lines cross. X comes before y. That's the ordered pair where those two lines cross. Could we have used substitution? Could we have isolated y over here and then substituted in there? Sure. It's a little bit messy because we're dividing by this a weird fraction with an over 2, and how does that go in here? And fractions are not the most favorite thing for most algebra students. But we could have. It was convenient here because y was already by itself, and elimination is convenient here because those coefficients can be made to match without too much trouble at all. All right, one more thing just to make sure that we're okay. Let's solve 2x minus 4y is 10, negative 4x plus 8y is negative 20. Well, okay. Substitution doesn't feel like it'll work because there's no y equals blah blah or x equals blah blah. So let's try the elimination thing. We'll try to make these match with opposite sign. 4 seems like a reasonable number, so we'll leave this equation alone, and we'll multiply by 2 up here so that we get 4x minus 8y is 20, and negative 4x plus, oh, wait a minute. What happens here? What happens here? What do we do with that? Well, let's think about this. Is this a true statement? Sure it is. It is undeniably true that 0 is 0. And 0 is 0 regardless of what x and y are. Well, what does that tell us? This tells us that the two lines are the same line. That's what it tells us. If we had gotten an unequivocally false statement here, we would have concluded that the two lines are not the same line, they're parallel, they never cross. But when we get a statement that is unequivocally true, it means that these two lines are the same line. So what's the solution? Well, the solution is every point that's on the line. And the way we say that is that there's a whole set of points that are the solution. They're the set of all points x, y such that, and then you just write either of the equations down because that's fine either way. Either of the equations represents the line. And so we say that there are infinitely many solutions. Not that all points are solutions, but that there are infinitely many solutions, and they all lie on this line. Well, I hope that that is somewhat helpful as you process the things that you read about. And when we gather in class, we'll look at some applications, and we'll hit the ground running as the semester begins. All right, very well. See you there.